Hey guys, so this is your review for the second test. Just a couple things from the last lecture that we had. Remember, I fast forwarded over like 2 or 3 slides because I said that they were too boring to do live, and I would do them via the internet. So just a little review. We talked about the high energy coast and the low energy coast, the Pacific coast, a lot of tectonic activity, a lot of high waves, so it's dominated by those cliffs with lots of erosion that look like this. And the Atlantic coast is passive with lots of sand, those really, really long sandy stretches with long, wide beaches and sandbars that look like this. And then you've got the Gulf Coast, which is even more passive with very small waves and small tidal range, very passive, and you get these barrier islands and large deltas. Okay, so those three kinds of coast. And now the slides that we fast forwarded last time. So erosion, what causes erosion? This list of things that cause the rocks to erode. So freezing and thawing, when water gets in between rocks and it freezes and thaws and freezes and thaws, it breaks the rocks apart. Plants that burrow. Abrasion is when sand blows into a rock or when wind blows the sand, it abrades. Dissolution is when the rock actually dissolves. And mass wasting, we saw that. Remember, I showed you pictures of mass wasting when you saw the whole side of the cliff come down, like in a giant storm or in an earthquake. The whole cliff comes down, and you saw the house coming down. So you saw that in class. You saw the pictures of mass wasting. And here is your erosional coast in California. So what causes depositional coast? These waves, these small little waves and currents that push the sand around, streams that bring the sand to the beach. You'll notice that abrasion and freeze and thaw both cause erosion and deposition because it's the abrasion of the rocks that cause the sand to deposit. And again, the freezing and the thawing breaks up the rocks and turns the bigger rocks into smaller rocks into sand, which is deposited on a depositional coast. And slumping is what it sounds like. Slumping, when the rocks or the mud just kind of slumps down and turns into a deposit. So here you've got your depositional coast. You can see not a lot of big mountains, sand, 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 sand. As far as the eye can see, all this is deposited. So this is these barrier islands that are formed when they're smaller waves that just keep bringing the sand down, down and depositing it. Here's your cartoon. Here's Texas and the Gulf of Mexico, where you've got these islands. This is the state of Texas. Look at how long and skinny this island is. It's an island made of sand, and they're all along the coast. These sand deposits, very flat. And you've seen this before. Here's the small wave bringing the sand toward the shore. That ways to shore, and there's only a little energy going back. So eventually, with smaller waves, the sand piles up on the beach. I guess this is just kind of a little review. In the winter, there's not so much sand, and in the summer, the winter has bigger waves, so it pulls the sand away offshore and erodes more. You can see the rocks kind of eroding. And in the summer, the sand is brought back onto the beach by deposition. We might as well go over this as a review as well. This is a review of a couple of different issues. So here's your deep water wave, a wave that's in water that's deeper than half the wavelength. The wavelength, the distance between two waves, right, is the wavelength. So when the wave is in water that's deeper than half the wavelength, it's called a deep water wave, and its speed is determined by its size. When a wave is in water that's shallower than half the wavelength, it's called a shallow water wave, and the speed is determined by the depth. So as the wave goes shallower and shallower, it slows down and it bends, and it's called refraction when the wave bends because it slows down. So you see these waves come in almost parallel to shore. So you see how they're coming in, they're bending almost parallel to shore. So they come in at a slight angle and then bring the sand like this, up at a diagonal slightly, and then the sand falls. Come here, mouse. Sand goes up at a diagonal, falls back down, up at a diagonal, falls back down. So the sand grains kind of move in a zigzag pattern down the beach, in a zigzag pattern like that. But the overall movement of sand is along this way. That's called the longshore current, sand moving down the beach. And here's the same picture. You can see the sand grains are going like this, the actual movement of any particular. So if you lost your flip-flop in the on the beach, and I've actually seen, I think I saw Finn do this, my own $50 Finn, kind of going like this. Come on, mouse. Going like this down the beach, faster than I could catch it, zigzagging away. But the net movement of sand, the longshore current is a current of sand that moves down the beach, being pushed by the waves that come in at a slight angle. Okay? Longshore current, a current of sand. Water moves on shore at an angle, returns straight down the beach. The sand moves down coast in a zigzag path. This net transport of sand is this way, and it's called a longshore current. There you go. And you can see this is a picture of the waves, or the storm's actually way out here. So the waves come in at this angle, but when they get close to the beach, you see they're coming in parallel like this, but then when they get close to the beach, they bend and bend parallel to shore, but not exactly to shore. So the sand gets moved down the beach. This bending is called refraction. This is all kind of review of waves also. So here's the cartoon of your sandbar moving. I think I put this in here because you guys aren't so familiar with it in California, because we don't have these huge sandbars and sand spits. A sandbar goes all the way across, and a spit just sticks out like that. They're kind of fun if you ever get to a place that has a sandbar and a sand spit. You can walk all the way out there. It's fun. You see the waves coming in almost parallel to shore and then bending parallel as they get close in this longshore current of sand. Here's just a picture. Again, we don't have many of these, or we don't have any of these in Southern California, but here's the land, here's the ocean, an island. You can see a road all the way down. It's very, very long, and you can even see through the water. It's all a buildup of sand. So these barrier islands come in a depositional coast. Okay, we also went through this really, really quickly, so I want to take a little bit more time. Part of a coast, an estuary is where fresh water mixes with ocean water, lots of life, very productive. There's 4 kinds. It can be a river that's drowned. So what happens is that when the ocean meets the river, that's why it's called a drowned river mouth. It's drowned by the ocean. Fjords, and we'll look at those when they're sandbars. And I don't even know what a tectonic estuary is, but maybe I'll learn it someday. So here's your river coming in. This is what a fjord looks like. Here's your barrier islands, and I guess that's what a tectonic is. Maybe we can find an example. I'm not sure. Here's your Chesapeake Bay, where the river is coming in from up here and meeting the ocean. So it's a type of a coast, an estuary. And here's a fjord. That's what that looks like. Another fjord, and you've seen lots of pictures of these sandbars. Okay, so now one more type of coast, I believe, or 2 more. Reefs and mangrove swamps also form coasts. So they modify the coastal shape. They can create calm water, and they block the waves, and mangroves create this maze-like network of channels. A mangrove is a kind of a tree, so I've got some pictures. So here's 3 kinds of coral reefs. You get a fringing reef, and that's when here's your new volcanic island, right, that's very young, and a coral reef. Come on, mouse. A coral reef is around it. Fringing reef, it's called. Then what happens is as the volcano gets older and starts to decay, it slinks down like this. So now the volcano is extinct and it's eroding away. But what's left is the reef around it, the coral reef. So that's called a barrier reef. And when you got a really, really old volcano where the volcano is completely eroded, all that's left is the coral reef, and that's called an atoll. So a fringing reef around a young volcano, a barrier reef around a middle-aged volcano that's begun to erode, and an atoll is around an old volcano that doesn't exist anymore, and all that's left is the coral reef around it. So they're all made out of coral reefs, 3 different kinds. So again, another kind of a coast. So your fringing reefs are right next to the land. The barrier reefs are separated by a lagoon, and atolls, again, they are an enclosed coral reef around where an extinct volcano once was. And here's your picture of a mangrove swamp, again, making up some areas of coast. These trees live in salt water. And here's another, God, that looks like it could be me, but it's not. I've actually done that. It's really fun to kayak through mangroves because it's calm, and you can see all kinds of birds live in here, and all kinds of other creatures live in here too. So it's fun to kayak around. There are mazes where you can go through them, but it's on certain types of coasts in the tropics are mangroves. Okay, we did talk about this in class, how humans always try to change the coast and make it how they want it, but of course it never works, so I'm going to click through these.